Centrifugal pump tutorial question number 6. The suction and discharge pipe of a pump are connected to a differential mercury manometer. The diameter of the suction pipe is 200 mm and the diameter of the discharge pipe is 150 mm. The specific gravity of the pump liquid is 0.81. The manometer reading is 600 mm. Determine the pressure head rise across the pump if the discharge is 115 liters per second. The center lines of the suction and the discharge pipes are at the same elevation. Here in this question, we use liquid that less than water, that density less than water. The specific gravity of the liquid is 0.81. Please remember how to convert the specific gravity into the density. And then, in this question, they ask you to draw a diagram showing pump and the manometer reading here. You could draw something like this. We have a pump here, and then we have inlet, and we have outlet. From the question, we know that the diameter of inlet is bigger compared to the diameter in outlet. And then this system connected with U-tube manometer like this. And manometer liquid here is mercury. In the question, they give you that the height here, manometric height in the manometer here is 600 millimeters. You should know how to draw the height here. We know that pressure at the outlet must be higher compared to the pressure at the inlet of a pump. So at this area, the pressure is higher. So the high pressure here will press the mercury here, and then the difference of the level is 600 millimeters. So the relationship for this question can be determined by using Bernoulli equation. So we have point 1 as the inlet and point 2 as the outlet. So head of pump can be shown as HP. Because the center line here is on the same elevation, we could say that Z1 is equal to Z2 is equal to 0. Then we could calculate the pressure at point 1 here and point 2 here by using the idea of U-tube manometer. You already know how to calculate this because we already learned about this in Fluid Mechanics 1. So I simplify the calculation here. We could say that P1 minus P2 over rho g is equal to 9.4741 meters. Then, because we know the value of flow rate, we know the diameter for inlet and outlet, for sure we could calculate what is the value of velocity at inlet and velocity at outlet. From that calculation, we could get V1 equal 3.66 meter per second and V2 is equal 6.51 meter per second. We substitute all the values, we get head of pump is equal to 10.9514 meters.